So today I am going to begin elasticity. What is elasticity? So elasticity is that property of any object, or it is the property of the material of any object, by virtue of which it opposes any change in its shape and size when the deforming forces are applied. Means when the deforming forces are applied, then it opposes any change in its shape and size. And as soon as the deforming forces are removed, it regains its original shape and size. For example, here, at present it is straight. If you apply the force, what will happen? It will bend. But as soon as the forces are removed, once again it regains its original shape and size. Here you can see, this is mobile cover. Its shape is this. When you apply the force, what will happen? It will be deformed. इसका shape क्या हो जाएगा? Deform हो जाएगा. On removing the force, what will happen? It will regain its original shape and size. Once again, it will regain its original shape and size. For example, here, if you apply the force on this, it will bend. But if you remove the force, once again it will regain its original shape and size. So this property, because of which body regain its original shape and size on removal of the deforming force, is called the elasticity. Means what is elasticity? It is that property of the material of any object by virtue of which it returns back to its original shape and size. It occupies to its original shape and size when the deforming forces acting on the body are removed, is called the elasticity. Now see here two kind of forces are acting upon it. One force which deforms the body, one force which deforms the body, one force which is deforming the body, that force is acting on this. And another force which bring back the body to original shape and size on removal of the deforming force. मतलब दूसरा फोर्स कौन सा है? डिफॉर्मिंग फोर्स को रिमूव करने के बाद द फोर्स विच ब्रिंग बैक द बॉडी टू द ओरिजिनल शेप एंड साइज, दैट फोर्स इज कॉल्ड द रिस्टोरिंग फोर्स. That force is called the restoring force. Means here two kind of forces are acting. One is the deforming force, which produces deformation in the shape of the body or in the size of the body or in both. And another force which bring back the body to the original shape and size, because of which body regain its original shape and size on removal of the deforming force, which is called the restoring force. Hereafter we will call it as DF and this as RF, restoring force. Now there is a term limit of elasticity. Limit of elasticity. Every body is elastic up to a certain value of deforming force. For example, here, this, it will return back, it will retain its property of elasticity. What is elasticity? It is the property of returning, it is the property of occupying the same shape and size on removal of the deforming force. So it is elastic up to a certain value of deforming force. If you increase the deforming force to a very high value, it will be permanently deformed. Similarly here you can see, it is elastic only up to a certain value of deforming force. But if you increase the deforming force to a very high value, for example here, when I will increase the deforming force to a very high value, what will happen? Whether it will return, it will not 100% return to the original shape and size. Up to a certain extent it can occupy to the original shape, but it will not be permanently returned. For example, here its shape is what? Its shape, you can see it is cylindrical. If you apply the force, it will be deformed. On removal of the force, once again it will return back to the same shape and size. But if you apply the deforming force of a very high magnitude, deforming force of a very high magnitude, what will happen? It will be deformed. It will be deformed. It is clear? Similarly here, if you apply the deforming force of the high magnitude, it will be permanently deformed. So every body is elastic only up to a certain value of deforming force. So that maximum value of deforming force up to which the body remain elastic is called the limit of elasticity. It's called the limit of elasticity. What is the limit of elasticity? It is that maximum value of deforming force up to which the body remain elastic. That is called the limit of elasticity. And it depends material to the material. For example, if you take two wires, one is of rubber wire and other is of steel wire, which can bear a deforming force of greater magnitude. So obviously it is steel. It can bear a deforming force of greater magnitude. While if you apply the same force in the rubber, it will be broken into two parts, or it will be permanently elongated. Its length will be permanently elongated. It's clear? Now there are two more things. Perfectly elastic bodies. Elastic bodies and perfectly plastic. What is perfectly elastic and perfectly plastic bodies? So see here, neither any body is perfectly elastic nor any body is perfectly plastic. What is the perfectly elastic? The body which return back, which occupies 100% of its original shape and size, even at the microscopic level. Even at the microscopic level, means not only at the outer appearance, even in terms of the intermolecular distances also. If it returns 100% of its original shape and size, then we will say that it is perfectly elastic. Similarly, perfectly plastic is what? Which do not occupy its original shape and size at all, which do not return at all to the original shape and size on removal of deforming force. That is called the perfectly plastic. But it is found that on removal of the deforming forces, some bodies return back to the original shape and size very largely, up to a high extent, while some are returning to very less. For example, if you take any body which is made of this material, quartz, on removal of the deforming force on any body which is made up of this material, what will happen? Almost it will occupy 95% of its original shape and size. Means almost completely it will return back to its original shape and size. Therefore, it is considered close to the perfectly elastic body. It is considered close to the perfectly elastic body. But if you take wet clay, if you take the आटे की लोई, what will happen? जिससे रोटी बनती है आटे की लोई, you will find that on applying the force, it get deformed. But on removing the force, it do not return to the original shape and size. It get permanently deformed. It is clear? So here we see that any material, any body which is made up of wet clay, it returns only up to 4 to 10% of its original shape. Largely do not return. Therefore, it is considered close to the perfectly plastic body. Close to the perfectly plastic body. Now see here, Now I am going to explain you some terms related to the elasticity. So, see here. There is one term, stress. What is stress? So, see here. There is one term, stress. Stress is defined as the restoring force acting per unit area of cross section. Restoring force acting per unit area of cross section. Per unit area of cross section. That is equal to restoring force, or simply not per unit area, you can cross section, only per unit area. Restoring force upon area. Restoring force upon area. Now see here. Here there is a body which is hanging from a rigid support. There is a thin wire which is hanging from the rigid support. You can see here. This is a thin wire which is hanging from rigid support, and suppose its length is capital L. How much is its length? Capital L. Now here I have suspended some weights from the lower end. Some weight has been suspended from it. By suspending some mass, here weight has been suspended. Mass is m, then how much weight will act? mg means how much force will act on the wire? mg force is acting on the wire. Means what is the deforming force? It is equal to F equals to mg. It's clear. Now this force is acting on this cross section of the wire. It is acting on this cross section of the wire. It is acting on this cross section of the wire. Here you can take area of cross section as A. Area of cross section on which the force is acting is E. So see here, because of this force which is acting as the deforming force here, its length will be increased. Its length will be slightly increased. Suppose the length becomes this. You can see here, let the length now becomes this is the original length, capital L, and there is this increase in length. It is clear. And here this is the mass which is suspending. This is the mass which is suspending here. Means the length which has increased by small l. Now see here one restoring force will set up on the body, and that restoring force will act in what direction? So that will act opposite to the deforming force. Restoring force will act always opposite to the deforming force, and within the limit of elasticity, restoring force will be always equal to deforming force in equilibrium. In equilibrium. It's clear? In equilibrium, within the limit of elasticity, restoring force will be always equal to deforming force. Here deforming force is mg, deforming force is F. Now see here, if you remove the deforming force, if you remove this weight, if you remove this weight which is shown by the yellow color, what will happen? This cross section will once again move from here to here. This cross section will move from here to here. Actually, it is acting here. This is acting in vertically downward direction. Restoring force will act in upward direction. Because of the restoring force, it will once again return back to the same position. Means ये cross section जो यहाँ है अब यहाँ आ जाएगा. Wire will occupy to the its original length. So we will remember that restoring force always act opposite to the deforming force. And within the limit of elasticity, restoring force is equal to the deforming force in equilibrium. It is clear? So it is the restoring force acting per unit area of cross section, and within the limit of elasticity we can also write this as dF upon E. Means what is stress? Stress is simply force upon area. Force upon that area on which the force is acting. वो एरिया जिस पर क्या है फोर्स एक्ट कर रहा है, दैट इज द स्ट्रेस. व्हाट विल बी द यूनिट ऑफ स्ट्रेस? स्ट्रेस फोर्स यूनिट न्यूटन, एरिया की यूनिट मीटर स्क्वायर. इट विल बी न्यूटन पर मीटर स्क्वायर. नाउ सी हियर, depending upon the type of deformation, there are three kinds of stresses. One is the longitudinal stress. Longitudinal stress means which developed when there is the change in length. Which develops when there is the change in length. Here change in length is acting here. It is developing when there is the change in length. So this is the stress which is acting here, that is called the longitudinal stress, F upon E. It is clear? There is another volume stress. What is volume stress? You can see here normal stress or volume stress. See here. Here there is a body of spherical shape. Body is of spherical shape. Now if the force is acting uniformly from all the direction, what will happen? There will be the change in volume. Its volume will be slightly reduced, and because of that some stress will be developed. Restoring force will be produced, therefore stress will be developed. Suppose now its shape becomes this. Shape is same, but the size has reduced. Shape is still spherical because the forces are acting from all the directions uniformly. Suppose its volume is V, then what will be its volume? V minus dV. It is clear? Here deforming force is acting from this side. It is clear? Therefore, restoring force will act from inside in outward direction. Restoring force will act from inside in outward direction. It is clear? This is the restoring force. If you remove these forces which are applied from the external side, because of these restoring forces, it will occupying the same volume. It is clear? So here stress which is developed due to the change in volume, that is known as volume stress, we are sometimes also call normal stress. Why do we call as normal stress? Because stress is acting normal to the surface. Force is acting normal to the surface. So that is called F upon E. And if, as we know that, if force is acting normal to the surface per unit area, that is called the pressure. Force is acting normal to the surface, That is called the pressure. If it is acting per unit area, then that is known as pressure. So here volume stress will be equal to the pressure. It is clear? Now after this, there is one more, shearing stress. What is shearing stress? Which produces change in shape, no change in size. If you see in these two, what is changing? Shape is not changing. Before and after elongation, shape of the wire is still cylindrical. Before and after compression, here shape of the body is still spherical, but the size has changed. Here length has become capital L plus small l. Here volume has become V minus dV. V minus dV. But now I am going to explain shearing stress which is produced due to the change in shape. Due to the change in shape. See here. Shearing stress. Here there is a body which is of the cuboid shape, kept over the surface. Some surface it is kept. Here lower face of the body has been fixed. जो lower surface है body का, that has been fixed. Body is of cuboid shape. Now some force is applied on the upper surface in the forward direction in the tangential way. Deforming force F is applied tangentially to the surface. It is acting tangentially to the surface. It is clear? This force F is acting tangential to the surface. It is not being pressed. It is acting tangentially. Because of this tangential force, what will happen? This upper surface will move in the forward direction. It will move in the forward direction. It is clear? It will move in the forward direction. It is clear? Here both the bodies are situated on the same surface and in between same parallels. Therefore, their volume will be same. There will be no change in the volume. Volume will remain same here. It is clear? Volume will be same. But what will happen? Shape has changed. In first case, it is rectangular shape. In the second case, it is in the parallelogram shape. It is clear? So you can see here, what will be the stress here? Force is acting F. So what will be the restoring force? Restoring force will act in this direction. That will be also equal to F within the limit of elasticity. If we assume this area as A, area of this top surface as A, then what will be the shearing stress? Shearing stress will be equal to F upon A, restoring force acting per unit area of cross section. Now after this, I am going to explain you another term, that is the strain. That is strain. What is strain? So strain is defined as fractional change in the dimension of the body. Fractional change in the dimension of the body on applying the deforming force. Deforming force लगाने पर जो fractional change हो in the dimension of the body. Means what is the fractional change? It is the change in dimension upon the original dimension. Change in dimension upon the original dimension. Here dimension will be characterized by the length. Here dimension is characterized by length. It is clear? Here dimension will be characterized by its volume. It is clear? In case of the spherical body, here dimension will be characterized by the volume. Here there is another type of strain because this strain is developed due to the change in shape. So see here, depending upon the type of deformation, there are three types of strain. Strain already I have told. What is strain? It is the fractional change in the dimension of the body. Means change in dimension upon the original dimension. So depending upon the type of deformation, there are three types of strain. One is longitudinal strain. Longitudinal strain. What is the longitudinal strain? Here dimension is characterized by length. So change in length upon original length. Change in length upon original length. Change in length is small l, original length is capital L. What is the unit of strain? There will be no unit because it is the ratio. Now in case of this spherical body, its volume in the beginning is V, afterwards volume becomes V minus dV. So here strain develops in its volume. So there will be the volume strain. What will be the volume strain? Change in volume. Change in volume is minus dV. Why do we write minus dV? Because there is the decrease in volume upon original volume with V. It is clear? Then the strain which develops here, that is called the shearing strain. Shearing strain. Because this strain is developed because of the change in shape. You can see here, this vertical wall has tilted by an angle theta here. Vertical wall has been tilted by an angle theta. कितना आगे tilt कर गई theta angle. So this theta will be the measure of shearing strain. This theta by which the vertical wall tilts in the direction of deforming force, that will be the measure of shearing strain. It is clear? What will be its value? Its usually value will be 3 to 4 degree, not more than that. It will not be 10 degree or 20 degree theta. Now you can write in other way also, since theta is a very small angle, therefore theta will be equivalent to tan theta. And what is tan theta? Perpendicular upon base. So if you take this distance as x and this distance as capital L, then what will be theta? Equals to tan theta, that is x upon L. Now all of you see here, what is x? It is the distance by which the movable surface moves in the direction of deforming force. It is the distance by which the movable surface moves in the direction of deforming force. And what is capital L? It is the perpendicular distance between movable surface and fixed surface. Capital L is the perpendicular distance between movable surface and the fixed surface. So this is all about in the lecture 1 of the elasticity. In the lecture 2, I will explain you Hooke's law and coefficient of elasticity.